Section 8.5, exponential and logarithmic equations. Our objectives are to solve exponential equations and to solve logarithmic equations. Now, just to look at exponential equations first, we have b to the cx power equals a. For something to be an exponential equation, you have to have a variable as an exponent, otherwise it would not be an exponential equation. Remember that when we were solving these equations that we had, when we did logarithms, we put it in exponential form, and we said if this right here, if we have a to the x power equals a to the y power, something with the same base, then you know that that only works if and only if the exponents x and y were equal to each other. Another property that we have is the property of equality for logarithmic functions. So suppose b is greater than 0 and not equal to 1, and a and c are positive, then if we have the log base b of a equals the log base b of c, then that only works if and only if a is equal to c. So it kind of is the same as what we have up here, except for instead of bases, we're using the log of a base of a number and the log of the same base of a number. And so that means in order to solve something, we can just take out the logs if it's equal to the same base. For example, if I want to solve this problem right here, 2 log base 3 minus 1/4 log base 3 of 16 equals log base 3 of x, well, the first thing that I want to do is I don't like to have more than one logarithm in my equation. So now is when we're going to use our properties of logarithms to get rid of that. So the first thing I would do is take this take the 2 in front of the log and bring it up as an exponent. Same thing with this right here. So when I do that, I have the log base 3 of 6 squared, and you can take up the negative if you want, or you can leave it as a subtraction problem. It doesn't really matter. I'm going to leave the negative in front. So minus the log base 3 of 16 to the 1/4 equals the log base 3 of x. And now I can keep going because I can simplify. 6 squared I know is equal to 36. And 16 to the 1/4 you can do in your calculator, it's 2. So this would be minus the log base 3 of 2 equals the log base 3 of x. Now I can combine this log and this log together using the quotient property. So I can combine it as 1 logarithm base 3, and then you take 36 and divide it by 2. And then for the next step, we just divide. So the log base 3 of 18 equals the log base 3 of x. And now by the property equality of logarithmic functions, we can finish solving this by saying if we know this is log base 3 and this is log base 3, therefore this number and this number have to be the same, so we can just say that 18 is equal to x. And that would solve my equation. So again, that's using the property of equality. Now, before we solve those exponential equations, we are going to talk about the change of base formula. So to evaluate a logarithm with any base using this change of base formula, what we do is that m, we change it into base 10. So this would be the log base 10 of m divided by the log base 10 of b. So notice that the base goes on the bottom and the larger number that you're taking the log of goes on the top, and this is base 10 formula change. So this is what we're going to use in our equations to help us solve some of these exponential equations. So for example, we want to solve each equation, round to 4 decimals, and check our answers. For the first one, if I look here, remember before when we said we were solving exponential equations, we wanted to see if we can get the same base. Well, if I look at a here, I know that I can never make 3 into a base of 4 and vice versa. So because I cannot make those the same base, this is when I'm going to write it in logarithmic form and then use that in order to help me solve this exponential equation. So I would write this as the log base 3 of 4 equals your exponent x. Now I can use my change of base formula in order to solve what I have right here. So x is going to be equal to the log base 10 of 4 divided by the log base 10 of 3. So if we plug this into our calculator, we can just do the log of 4 and don't forget to close those parentheses, divided by the log of 3, and we're going to round our answer to 4 decimal places. So that means that 1.26185 means it's going to round up to 9, so that's going to be our solution. So x would be equal to 1.2619. Now these answers are easy to check because we can just plug this in for x to see if it's equal to 4. So if I go back to my calculator, if I do 2 to the answer that I just got, I should get, not 2, sorry, 4 to the answer, 3 to the answer I just got, oh my goodness. 3 to the 1.2619. Notice we get 4. Now, this one has rounding error because I didn't use the whole answer. I rounded to the 4 decimal places, so that's why it's not exactly equal to 4. Had I used my answer from before, I would have gotten equal to 4. So looking at the next one, and I'm just going to make a little note up here. Remember that to solve exponential equations, you're going to use exponential, or shoot, use logarithmic form. So for the next one, same thing. I can't make base 6 and base 21 be the same, so that means I'm going to use my logarithms in order to solve this. So remember, your base stays your base. This would be the log base 6 of 21 equals my exponent, 2x. Now to solve this, I can do my change of base formula over here, and then I'm going to divide that answer by 2 to solve for x. So my solution is going to be the x is equal, so let's do 2x is equal to the log base 10 of 21 divided by the log base 10 of 6 in my calculator. So when I do that whole answer, I'm going to then divide it by 2. So in my calculator, I would have the log of 21 divided by the log of 6, all divided by 2 for my solution. So plugging that in my calculator, don't forget again to make sure you put closing parentheses for each of your logs, otherwise you'll get a different answer. And then take that answer and divide it by 2, and you end up with 0.849, and we're going to round to 6 right here. And you can check your answer by doing your original equation. So 6 to the power of 2 times the answer that we just have should give me 21, in which it does, so our answer checks out. So it's easy to check these. So for this one, we get x is equal to 0.8496. So let's go to the next one. So for this one, C, again, we can't get the same base, so I'm going to use logarithms in order to help me do this. So if I write this in logarithmic form, log base 3 of 101 equals my exponent, x plus 4. So again, I'm going to do this part in my calculator. The log base 10 of 101 divided by the log base 10 of 3 equals x plus 4. If I do this part and round to 4 decimals in my calculator, I would actually probably wait to do that and just subtract the 4 rather than having a lot of rounding error. So in my calculator, I'd plug this in first with the log 101 divided by log 3, enter. And then I'm going to subtract 4 for my answer because it's equals x plus 4. So subtract 4 and you get 2.00, round your answer to 9. So again, we did x is equal to the log of 101 divided by the log of 3 minus 4 because we wanted to get x by itself. So x was equal to 0.2009. And of course, you could always check your answer using your calculator, doing 3 to the answer plus 4, and you should get 101. So D, we're going to do the same thing, except for if you notice from D, it's a little bit different than all the other problems that we had. Why is it a little bit different? Because of this -1 right here. Notice that in all the other problems, we had the exponential part by itself on one side of the equation. So that's the exponential part. Over here, this was the exponential part, and this is the exponential part. So before we can solve these problems, we always want to have the exponential part on one side of the equation by itself. So I need to get this by itself by adding 1 to the other side. So you get 5 to the 2x plus 7 equals 9. And then now I can't get 5 and 9 is the same base, so I'm going to use my logarithmic form. So this would be log base 5 of 9 is equal to 2x plus 7. So then in my calculator, I'm going to use a change of base formula. I'm going to do the log base 5, or sorry, the log base 10 of 9 divided by, and this number goes in the bottom with the 5, so log base 10 of 5 equals 2x plus 7. So in my calculator, to solve for x, I'm going to have to subtract the 7 and then divide all of that by 2. So x is going to be equal to the log of 9 divided by the log of 5. And then you're going to subtract 7, and you're going to divide this whole answer by 2. So just to show you how to plug it in, log 9 divided by log 5, enter. Then I would subtract the 7 and divide by 2 to get my solution, negative 2.017, and I'm going to round to 4. And again, you can check your answer by doing 5 to the 2 second answer, and then plus 7 minus 1, and you should get 8. So the solution, x would be equal to negative 2.8174. So that's solving exponential equations. Now, we already talked about the change of base formula, so let's just do a couple more change of base practice problems. For this one, if I wanted to do the change of base formula, again, the number that's smaller goes on the bottom. So this is going to be the log of 400 divided by the log of 5, and if you do this in your calculator, you end up with this being equal to 3.7227. Well, we're not done because that's the first part. It says use a change of base formula to evaluate each logarithm. Then the second part says then convert each logarithm to base 4. So when we're doing this change of base formula, we used base 10 in order to help us do that. So for that, I use a change of base formula to figure out this number right here. Then I know that the log base 5 of 400 is equal to that number, so 3.7227. Well, now the problem is I want to change this into log of base 4. So I want the log of base 5 of 400 to be equal to the log base 4 of some number. So I have to figure out what this number is going to be in order to make base 4 work. Well, one thing I can do, which I just did a second ago, is I already know what this is equal to. We used our change of base formula to find the log base 5 of 400. That's this number right here. And so we can replace log base 5 of 400 with the number we just found. So we're going to do 3.7227 equals log base 4 of something. So the best way to solve a logarithmic equation, which we said before, is to put it in exponential form. If I put this in exponential form, remember the base stays the base. So if it's log base 4, that becomes my base in exponential form, and then this becomes my exponent, because remember logs are always equal to your exponent. So 4 to the 3.7227 is going to give me my value of x, and I can use my calculator in order to do this. So I'm going to even just show you first, I'm going to do the log of 400 divided by the log of 5, enter, and then really I'm doing, and so I don't have to have a whole bunch of rounding error, I'm going to do 4 to that answer, which gives me this number right here. And then let's just look at what happens if I did the 4 decimal places. So if I did 3.7227, I end up with about the same number. It's just a little bit of rounding error, so it's okay if you want to use either two. Let's go ahead and just use our rounded one. So 174.2965 is going to be the solution that I'm going to use. So x would be equal to 174.2965, and we're not done because we actually have to convert it to base 4. So I want to write this in logarithmic form. So this would be, and I have just write it down here, the log base 4 of 174.2965 would be my second answer, because this is equal to the log base 5 of 400. Now it's just the log of base 4. And if you do the log of 174.2965 divided by the log of 4, you should be equal to this number. So it's an easy way to check your answer. So let's do another practice one, because these are sometimes hard for students. So let's look at this next one. We want to convert this to base 4, and we also want to figure out what the logarithm is equal to. So first I want to figure out what this is equal to. So x is equal to the log of 12 divided by the log of 6. When you do that in your calculator, you get 1.3869. Now that I have that, I want to figure out the log of 6, base 6 of 12. I want it to be equal to the log base 4 of some number. I know that this is equal to this number here, so I'm going to just replace it in my equation. 1.3869 equals the log base 4 of x, and then to solve this I just have to put it in exponential form. So 4 to, and this is my exponent, 1.3869 equals x. So then in my calculator, if you plug that in, you get 6.8391. So then my other answer, so this is my first solution, my second solution would be the log base 4 of 6.8391. And that changed it into base 4. And again, you can check these on your calculator if you want. If I do the log of 6.8391 and divided by the log of 4, because that would be base 10. That's my change of base formula. I should get what this is equal to right here, 1.3869, which I do. So therefore, I know I did it correctly. So these would be my two answers here and here. So for the next problem, it says, use the change of base formula to evaluate the logarithm and then convert to base 8. So I want you guys to do this on your own. Now, the last part we're going to come to is solving logarithmic equations. An equation that includes a logarithmic expression is called a logarithmic equation. In some cases, you must use the properties of logarithms to simplify expressions before solving the equation, because you only want to have one log in your problem on one side of your equation in order to solve it. And just like in order to solve exponential equations, we use logarithms. To solve logarithm equations, we can use exponential form. So looking at A here, if we want to solve each equation, I have the log, and it's base 10 if it's not written, of 3x plus 1 equals 5. So I want to figure out what x is going to be equal to. In order to do so, I'm going to write this in exponential form. So I know the base is 10. So 10, this is my exponent to the 5th power, equals 3x plus 1. And all I have to do is then solve for x. So I'm going to do 10 to the 5th minus 1 equals 3x. So x would be equal to 10 to the 5th power minus 1 divided by 3. And I can just plug this into my calculator. So if I do this, I have 10 to the 5th. And then I'm going to subtract it from 1. Enter. And then I'm going to divide that answer by 3. And that gives me my solution, 33,333. So let's go ahead and do the next one. So the next one's just similar to the one we just did. So the log base 10 of 7 minus 2x equals negative 1. Again, in order to solve this, I have to write it in exponential form. I know the base is 10, so this would be 10 to the negative 1 power equals 7 minus 2x, and I'm just solving like I did the last problem. So the next thing I'm going to want to do is subtract 7 from both sides, so 10 to the negative 1 minus 7 equals 2x, and I could keep on going, so x is going to be equal to 10 to the negative 1 minus 7 divided by 2. And if you do all of this on your calculator, you would end up with 3.45. And you can check your answer by plugging 3.45 into your equation. And since it's base 10, you should be able to get the answer. All right, some more problems. Now, these two problems are different than the last two problems that we did because notice that you don't just have one logarithm in the equation, you have two logarithms. Because we have two logarithms, that means you're going to want to combine it into one. You don't ever want to work with two logs in your equation unless it's on the other side, the equal sign. Then you can use your first property that we did, the first equation. So for this, I'm going to use my power property first. To bring that up as an exponent, that's the first thing I always do. So this would be the log of x cubed minus the log of 2 equals 5. And then I want to combine both these together by using my quotient property. So this would be the log of x cubed over 2, and the 2 is on the bottom because it's being subtracted from the log of x cubed. Now that I have this problem right here, I can't do anything more, so now I can go ahead and put it into exponential form. So the base is 10, so 10 to the 5th power equals x cubed divided by 2. So how would you solve the rest of this? Well, if we're dividing by 2, that means I'm going to multiply both sides by 2 to get rid of that. So I have 2 times 10 to the 5th equals x cubed. And then how do you get rid of something that's to the 3rd power? You take the cube root of both sides. So when I do this in my calculator, I would do the cube root of 2 times 10 to the 5th power. And so in my calculator, I'm just going to do it all separately. So I have 10 to the 5th power, enter, times 2, enter, and then I'm going to take the cube root of that answer, so you can get the cube root by going to math and number 4 and second answer, or you can just type it in, enter. And when I do that, this gives me my solution, so 58.480, and I'm going to round this number right here to 4 because it's 5 right there for the next term. So x is equal to 58.4804. All right, so looking at the next one, same type of problem, except for I don't have to use the power property. Now I'm just using the quotient property. So again, I want to combine this into one log. So this would be the log base 10 of 6 divided by 3x equals negative 2. Of course, we can reduce 6 over 3, so this becomes log base 10 of 2 over x equals negative 2. And then I just want to go ahead and continue. If I solve this, I can't do anything right now until I put it in exponential form. So this would be 10 to the negative 2 power equals 2 over x. And this one's a little bit harder to solve because we have x in our denominator instead of our numerator. So you can put this over 1 and cross multiply to help you solve. So if I cross multiply, I get x times 10 to the negative 2 power equals 2. And then if I solve for x is going to be equal to 2 divided by 10 to the negative 2 power. And if I plug that into my calculator, 2 divided by 10 to the negative 2, enter. Notice I get 200, so 200 would be my solution. All right, so we have one more problem to go and then we are finished. For this problem here, we have the log base 2 of 2, the log base 2 of 3, the log base 2 of 4x equals 3. To solve this problem, first we need to combine all these into one logarithmic equation using our properties of logarithms. So this would become the log base 2, and when I have things being added, I multiplied. And notice I don't have any numbers in front of my log, so I don't have to worry about taking those up as powers. If I did have numbers in front of the logs, I would take those up first. So log base 2 of, and I'm going to have 2 times 3 times 4x equals 3. And then I can go ahead and simplify from there. So I have the log base 2 of 24x equals 3. And now I can just put this in exponential form in order to solve. Now my base is 2 instead of base 10, so I'm going to do 2 to the third power, because remember this is logarithms always equal your exponent, equals 24x. Now to solve 2 to the third I know is 8 equals 24x, and the last step to solve for x, so x is equal to 8 over 24, and all we have to do is just go ahead and divide, so this would be equal to 1/3. So make sure you bring this with you to class, and we are going to do a bunch more examples. The main thing to remember is that you can only have one log in your equation, and when you're solving logarithmic equations, you use exponential form to help you. When you are solving exponential equations, you're going to use, just like we did over here, you're going to use logarithmic form in order to help you solve.